mic, and it's recording from the right channel, and it looks okay. I'm just checking the level here. Looks like it's going to be okay. All right. So what we'll do today is to go ahead and talk about the homework assignment. Let me finish some of this stuff here first, because I want to maximize the amount of space. And panel preferences, make it auto hide. So this way we get a little bit more space. And down here as well. Panel preferences, auto hide. Okay. I cannot make it too low because I can see that some of you may get obstructed, because of the monitors in front of you. So this is probably okay, and I can make it a little bit wider. But the class is not quite here yet. I'm going to wait just a little bit longer, and since we're waiting, we can go take a look at some of the stuff that I find over the past few days, or mostly yesterday. This one is just a ranting piece. Somebody wrote this and say, well, now we have an app explosion. A lot of apps are useless, pointless, or really of low quality. But you know what? That's exactly the nature, of a how do you call that? I cannot remember the term. But the whole point is, bad apps, people won't buy, people won't install, and they will just go away at some point. Good apps, people will use it and buy it, and they will basically stay sustained.
Like an ecosystem?
Yeah, the ecosystem, free market. Okay, because some people seem to be suggesting that we have to police, what type of apps, can be available at a market. So that's kind of more like a policing, what type of app can be distributed. But this one is kind of interesting too. If you click that link, it goes to the Google Play Store, but this particular app is kind of interesting because it will, one really expensive mobile device, and that mobile device turns out to be the Tesla Model S, which is a $100,000 car. It's a full electric car, but that's basically where things are going. In 5 years, at the most, I'll give it 5 years at the most if it's not already done. Some cars will have, an Android-powered or otherwise, iOS, Android, pick one, dashboard. In other words, the entire dashboard or the control panel is one touch screen. One big touch screen, and then everything is going to be done through that interface. It's not new. This is nothing new. Most newer cars, come with a touch screen already. That has been the case since what? 10 years ago, some of the more expensive cars. But the problem is they don't have a unified user interface. BMW has its own, Acura has its own, Toyota has its own, and so on and so forth. Ford definitely has its own too. If you read a lot of car reviews, that is one of the issues, with modern cars is people don't know how to operate things anymore. In the past, how do you operate a radio? Well, you turn the volume knob on, that's an on-off button as well as a volume control. There's another knob for frequency, so you dial in your station, you pop in your cassette tape, it plays the cassette tape, and when we had CD-ROMs or CDs, you pop in the CD and it starts playing the CD. These days, what do? Well, you use your iPod or Android to control the system, right? A lot of times that's what we do. So I think we'll start to see apps for at least the user interface part of a car, and it wouldn't be too far-fetched to see that cars can, at least for certain functions, interface with your mobile device. In other words, the kids in the back of a van can use their own mobile device to control the temperature, at least for the back of the van. They can dial it up, they can dial it down, they can control the fan speed and stuff like that. So that would not be, I think if it's not done already, within 5 years, I would expect most cars to go in that direction. The other thing about using mobile devices in a car was it was expensive to do. A touch screen, was expensive. The software that goes along with it is super expensive. It's not even the hardware that is prohibitive. It is, writing the firmware, the actual software that goes along with the touchscreen that is expensive. Because in the past, Toyota has its own development team to develop their own user interface, touchscreen thingy. Acura or Honda has their own team. BMW has their own team. But these days, they don't need to have their own teams anymore, because come on, how is it relating to this class?
We already have the Android architecture.
We have the Android architecture, and it's open sourced. Okay, it is open source. The only part that is not open sourced would be Google's own apps. Okay, the Play Store is not open sourced. Gmail is not open sourced. Okay, but there is a significant amount of infrastructure that is already open sourced. The development tool is mature. Okay, the operating system itself is mature. Okay, and then the last part has to do with the hardware being inexpensive. Okay, it used to be expensive to custom make a dashboard, touch screen. It is no longer the case. So I think that will change just about everything. Because has anyone disassembled the dashboard out of your car and see what kind of mechanical stuff is behind it? That's not cheap. Okay, that is not inexpensive at all to put a mechanical dashboard together. It is much cheaper to put an electronic dashboard together and have just a network cable connected to the rest of the car, which is what cars are doing these days anyway. Okay, most things are all electronic already, and your car has its own network system, typically called a CAN or controller area network, and we just need connectivity to Android and turn it into a dashboard. That's basically, I think, what's going to happen really soon. It's not just because it's fancy, it's because it is less expensive. So for those of you who are now in this class, taking this class, I think some of the market or job market for application development is going to be in car industry. I'm not kidding. I mean, this is actually where things are going. So that's one piece that I think is directly related to this class. This one is not too related to this class, so I'm going to skip that one. This one is kind of interesting. Some states are already outlawing wearing a Google Glass and driving at the same time. So if they catch someone with a Google Glass on while driving, that person can get a ticket. And Google has started to fight those legislature in those particular states. I think there are 3 states involved in this case. Of course, all of this stuff is going to be moot anyway. By year 2020, we'll have self-driving cars anyway. You can be using a laptop computer in front of you, and nobody cares. This one is not related to this class, and I think that's about it. Since this is an Android programming class, there's one more thing that I think you guys should know about. It's the Nokia X line of phones. Does anyone know what is a Nokia X line phone? No? Okay. Does anyone know that Nokia had a alliance, quote-unquote alliance with Microsoft? No? Okay, they have been releasing a lot of Microsoft Windows Phone through Nokia. And now it is taking a really kind of weird twist, because Nokia X uses Android as the basic operating system framework, but Microsoft, not Google, is writing the apps on it to make it look like Windows. Yes, that would be an appropriate expression. That's exactly what I thought too. So if you just go ahead and read the articles, you will find that most people do not seem to think that this is a great idea, using the Android operating system, but on top of that, use Microsoft applications to get the feel and look of the Windows system, basically. So something for you guys to kind of ponder upon. And are there any questions, any comments? No? Okay. All right, so if there are no questions, no comments, we're going to get started with today's class. And it's going to be a longer discussion today. And if you guys have any questions during today's class, you really need to ask questions, because we'll be working on the next homework assignment. Okay, I was in the process of making it, and then because of some other issues, I did not have enough time to finish it. So I'll go finish the description as we talk about the topic of NVA design pattern.
Is this the H2O thing you have posted?
Yep, it's partially up already, but it's not completely done yet. Okay, so we'll go to the slide here and go to the homework description. It's called H2O. It is a typical, this is quote unquote what I call a typical homework assignment, because what is involved here is you have to do your application development using Eclipse. At the end of the entire thing, you're going to zip up the entire folder, send it as one single file. I will unzip it, on my machine. I'll import it, and then I'll take a look at it. Okay, I'll run the app, I look at the code, and basically use that as a grading criteria. All right, so the first thing we want to do is I'm going to get into the editor, because this is not entirely done yet. Okay, so I'll be expanding on the description as we go over this. There we go. And let's try to make it a little bit bigger. All right. The purpose of this assignment, and I'll probably turn it into a project. In other words, it'll be multiple phase. There'll be multiple phases to this particular quote-unquote homework assignment. Is to let you exercise GUI coding. Okay, we did a little bit of that with the other homework assignment, the TikTok homework assignment. But this time we'll also make use of the MVA, the model view adapter architectural design pattern. Okay, I know it is a little bit out of the scope of this class, but if there's any class within our curriculum that is the right place to introduce these kind of concepts, this class is the right place. So we'll go ahead and basically use this as an exercise to go through that process. In this case, because the application is relatively simple, we'll only use some use case diagrams, but not all of the use case diagrams available in the UML. The first one we'll make use of in this case is a use case diagram. You don't have to turn in anything, it's done for you already. So let me just explain what this use case diagram is really explaining. In the UML, or the Unified Modeling Language, a use case diagram is used to display or show why would anyone want to install and use your system. Okay, it applies to anything that is small, like an app, simple app, to anything that is really complex, like an online banking system or the information system of the entire, of a particular branch of the state government. Okay, so of course in those cases, you will have a lot of use cases and a lot of actors. In this case, we only have one use case and two actors. So let me explain what a use case is. A use case in this case, or this particular one, is called model H2O. In this case, model is a verb. It describes what the system is doing. So in this case, this app is modeling basically water. H2O is water. It has two actors. And when you look at each matchstick figure, each one is called an actor. So here's an actor, here's another actor. An actor represents a classification, not a single individual, but an entire classification of external agents that can interact with this system. So in this case, an actor can represent a classification of actual end users interacting with your application. It can also be something that is not a person, non-human. It is also possible that you are monitoring frost conditions, okay, and try to set up an alarm system. When it is, when temperature is too low, it is starting to freeze, or you'll have frost. You'll get an alarm and say, okay, you better protect your pipes now, because otherwise they will burst because of the ice, condition. Or if you drive, it will also tell you, okay, the temperature is now below freezing point, so you might want to be careful in case of black ice on the road. So that's why it is not necessarily a particular person. It can be another system. It just has to be external to the system that we are describing. Let's take a look at one particular actor. Let's look at this one here. The description is kind of informal. I just say someone who needs to know the state of water. In other words, this is someone that the system has to notify or let know of the state of water. Okay, is it freezing? Is it boiling? Or is it turning back into liquid? That person needs to be notified of any state change of water. But we also have another actor here. This actor here is labeled someone who updates environmental data. In other words, it can be a back end that interfaces with weather.com or weatherbug.com or one of those websites to monitor the actual environmental information. It can also be a simulator where you are the one who has a button or a slider to say, okay, I'm bumping the temperature up to 65 degrees now, okay, 100 degrees. Oh, okay, water should be boiling. Am I kind of making this one clear at this point or not? So this application is general. At this point, we don't know what it is. Besides, it is used to model H2O. It can be a children's application where they learn, that water can turn into steam, can also turn into ice. It can be just a simulator like that. It can also be an actual application where you get the alarm when it is if it's a freezing condition, when the freezing condition happens. So at this point, we don't really need to know which one it is. We just know that there are two types of external agents that are interacting with your system. So that's basically what the text is talking about here. Next, we draw a state machine diagram, and it's a little bit too big to fit in the entire screen. This is something that we have seen already. It's just that I am now starting to make it more formal and use the formal notation. So we'll go through these notations one at a time. Everything starts with this solid black circle, which is what we call its initial state. This is what starts the entire thing. Okay. So when the model starts, we start from that point. You can see there are three transitions coming out of it. Each arrow is called a transition. So we have one transition here, and one transition going to the other side, which is not shown on the screen at this point. Now each transition can have up to 3 components. Okay, I'm just showing you the other side of this. Now each transition can have up to 3 components. The first component is called a trigger. Okay, it's an event that is happening outside of the system. So this is something that is not synchronous to the system that we are trying to describe. In this case, all the transitions are triggered by temperature change. In other words, whenever the temperature changes, it can potentially cause a transition from one state to the next. But the first 3 transitions from the initial state, they do not have any triggers. In other words, we are not waiting for anything external to the system to perform one of the 3 transitions initially. Okay, so you can see that this one here doesn't specify a transition. It doesn't have temp change. It just has a condition, which is called a guard condition. A guard condition is a condition that has to be true in order for that transition to happen, even if the trigger is already present. Okay, so it's just a way to basically say sometimes even if the trigger is triggering, but if the condition is not met, the transition still does not occur. Are we doing okay so far with that? Okay. What is after the slash, in this case, is boil. We have condense, and we also have freeze over here. Those are actions. In other words, those are things that this model can do. Okay, which will basically translate into either methods in the model or something else. Are we still doing okay with reading the state machine diagram? Some people may have prior exposure to state machines for other applications, like in electrical engineering. State machines are used a lot to model, a lot of different types of machinery. Okay, all right. So we're going to go take a look at this part here. Okay, let's take a look at the bubbles. There are 3. Well, I shouldn't say bubbles, but there are 3 states here. One state is steam, one state is water, and one state is ice. So each state is an adjective or a noun. In this case, it is describing what is the current state of H2O. Because H2O is simply describing the compound. It does not describe the state of the compound. In this case, it has 3 distinct phases, or it's 3 distinct states: steam, water, and ice. Those are the 3 states of water. Are we still doing okay so far? Okay. Now, water can only be, quote unquote, can only be in one state at a time. So that means only one of these states actually describe water that we are trying to model in this particular case. When it is in steam state, it will remain in steam state as long as this particular trigger does not happen. In other words, to get out of the steam state, the only thing that can take it out of that state is temperature change. And yep, it has to have the, okay, first of all, a temperature change trigger has to happen from the outside, okay? An external agent can be monitoring the temperature, and when it changes, it will trigger, it will cause a trigger. The trigger itself is not sufficient to cause a transition because we have a guard condition in this case. The guard condition in this case is T, or the temperature, is less than 100 degrees Celsius. So when we have a temperature change and the new temperature is less than 100 degrees Celsius, then we go through the action called condense to go from steam back into water. Okay, is that okay? So right now it doesn't seem to have anything to do with app development because we're simply describing the behavior of water molecules. From water, it has two possible transitions out of it. One transition is to go back into steam when there's a temperature change and the new temperature is greater than or equal to 100 degrees Celsius. Then it goes through the boil action to go back into steam. The other transition out of water is when the temperature changes the temperature so the new temperature is less than or equal to 0, then it goes through the action called freeze to turn into ice, which is nothing new. I mean, this is all pretty much high school chemistry, and we know all this stuff already. So are we still okay with this description, this homework description up to this point? You do not have to construct the state machine diagram. It is already created for your benefit. Okay. So what we want to do is to look at this state diagram and say, okay, we are going to use this to form the basis of a model. Okay. So the back end of your application, which does not depend on how the user or something else is going to interact with your model, is going to be specified using just this state diagram. Are we still doing okay so far? Okay. And I basically ran out of time, after typing, this part here. In this diagram, each transition has up to 3 components. The guard conditions are in parentheses. Events are to the left of a slash. Okay, so this part, this part temp change is the only event. And actions are to the right of the slash, so that will be condense, boil, and freeze. Each action causes a state change, and as a result, the action should also notify a quote-unquote listener of the model of the state change. Are we still doing okay so far with this? What exactly is a listener? We use that term, in Android programming, but in this case, it is not specific to Android either. So what exactly is a listener?
Variable update.
Sorry?
Variable update.
Variable update.
The adapter.
Okay. Well, an adapter let us communicate with a listener. So what exactly is a listener? Event handler. Okay, somebody who will be notified of something. Okay. All right. So the homework description, kind of stops here. I'm going to continue to type when we have more to type here. But before we go, any further, with the homework description, what I'll do is I'm going to start up Eclipse. And the reason why I'm starting up Eclipse is I want to show you the previous example that was already done, and I'm going to use that as an example. And I'm going to use another folder in this case because it has to be in the mounted system. So it's in persistence, home, user, and workspace. Go. problem. That's fine. I think if I start, last time this happened to me, if I started again, the problem went away. So let's see if that fixes the problem. Could not find SDK folder. Open preferences. And we just have to point this to the place where it is actually located. Last time we were using the counter project as an example, and under counter, under the source, we have a few packages. The last package here, has the classes related to a counter as a model. So let's go take a look at this particular one. Okay, there we go. So this is the model of a counter. As a counter, there are several things that can serve as input or triggers as inputs. One thing is a request to increment. One is a request to reset the counter, and the other one, the last one, is the start condition, which is just to initialize the entire thing. Each trigger in this case is represented by a method. Okay, here's a method to for the trigger called increment. Somebody is asking or requesting that this counter be incremented. Reset, somebody is requesting this counter be reset back to 0, and also start, where someone is requesting that we start the entire model. This is the initialization. So that means every single trigger is now represented by a method. And in your homework assignment, I want you to do the same thing. Okay, every trigger should be represented by a particular method. And how many triggers did you see in the homework description in the state machine diagram? There's only one type of trigger. Okay, temperature change. So if I go back to the homework assignment here, there's only one trigger. The one trigger is temperature change. This one is a start, so basically from the initial state to one of these other states, you just use the method start to represent those transitions. Because they are not triggered by something external, it has to happen as soon as the model is created. Are we still doing okay so far? But we do have one thing that is missing in the other example. The guard condition itself is missing. In other words, the temperature of the temperature change somehow has to be passed to the model of water. And that means everything that you can use to trigger your model to do anything needs a parameter. What kind of parameter do you think they need? Temperature. Okay. So what I'm going to describe it here. Okay. So the first step here, I'm going to make sure that it is structured. Here we go. Okay, step 1. Write code for the model. Okay. Write a class to represent the H2O model. Okay. Kind of like the class that I used to represent a counter. Okay, so it won't be very different from that one. Okay. So I can say that you can borrow some code ideas from the counter class of the example. Okay, so going back to the class, counter class, you can see that each trigger is represented by a method. And then we have one special method here called setUIAdapter, and you can keep the same thing too. In other words, this is specifying who can be listening to my state change. Okay, so that is also important in your homework assignment. Although you may not want to call it UI adapter, you might want to call it just the listener adapter. Okay, who is listening to state changes of this model? Okay. So I'm going to put it here as well. Okay. So each trigger is represented by a method, and you have to look at the picture to find out how many triggers we have. The trigger method needs a parameter so that the new temperature is known to the model. And that part is missing entirely from the example. When you look at the example, let's say increment has no parameter. Because when we request that a counter be incremented, it is always incrementing by 1. Okay? And as a result, there's no need to use a parameter. When you're doing this homework assignment, when you say temperature change, it is not always going to change by 1 degree higher or 1 degree lower. So you will have to tell the system using a parameter what is the new temperature. And based on the new temperature, the code can basically perform the logic and say, do I need a state change? Is it crossing this boundary? If it is, then I need a state change. Are we still doing okay so far with this description? Okay. In this class, we also need to keep track of the current H2O state. Use a private instance member variable to do this. Okay? What do I mean by a private instance member variable? Do we have an example of a private instance member variable in the counter example? And can anyone remember the name of that particular member variable? Well, I mean, I'm not really asking you guys to memorize the entire program. It's called value, exactly. So if we switch back to this example here, we have value, which is local to this particular class, and it's an instance variable because it doesn't say static. And it is used in this case to keep track of the value of the counter, and you will need something similar to that to keep track of the state of the H2O that you're modeling. Now, how do you want to do that? It's entirely up to you. You can use this variable to store the temperature, okay, the current temperature. Because from the current temperature, assuming it is under 1 atmospheric pressure, you can infer the actual current state. And as a result, you can use that to trigger a state change whenever it is crossing the boundary. Am I making that clear? Okay. You can also just use a number to represent each state. In other words, you can use 0 to represent ice, you can use 1 to represent water, and you can use 2 to represent steam. But if you choose that representation, then you need a switch statement. Because every time there's a temp change, you need to look at the new temperature, but you also need to look at your current state to see if there is a new transition that that needs to happen. The reason why you need that is because if you're in water state and the temperature changes, it changes from, let's say, 40 degrees to 30 degrees Celsius. Would that trigger a state change? No. It would not. It would trigger it would not trigger a state change in our model because we are not changing phase. Water is still water. It's just cooler than before, but that is not reflected by our model. On the other hand, if the temperature was 99 degrees Celsius and now it is 101 degrees Celsius, then you have to trigger a state change because now it turns into steam. Is that okay? Is that making any sense? Okay. All right. So I'm going to write it down here also. Okay. You can decide how to track the current state. 2 options are fairly common. use an integer value for each state or store and track the current temperature in degrees Celsius. Okay. Are there any questions at this point about inside the model class how we are going to keep track of the state of the water that we are trying to model? No questions? Okay. You will need the start method to get everything started. The start method also requires a parameter to indicate the current temperature. Which means if I go back to, oops, wrong page. If I go back to this picture here, this transition is caused by the start method in your model class. But you have to pass the current temperature so that you can use that to determine what would be my current state. There's no real transition here. It is just, you know, from the initial condition to here, you have to decide, okay, I have to get into one of these three states, but the only way you can decide which way to go is to know the current temperature, which means the start method needs to pass a parameter, which is the current temperature. Is that okay? Yep.
Are we just assuming that the temperature is correct?
Yes, you're assuming the
correct
temperature
value.
is correct. Correct. Yep. Okay. Any other questions at this point? No questions? All right. Okay, now I haven't really talked about this UI adapter thing. You will need an adapter of some kind because you need an adapter to talk to a listener, okay? Somebody who needs to be notified or potentially be notified when there is a state change. So let me put that into the description here as well. The class also needs a private instance member variable to track, as a reference to an adapter object. This adapter object is the broker when there is a state change. Any state change will trigger this broker to inform one or more, any number of listeners to this model. Okay, so let's take a look at this sentence here. The class also needs a private instance member variable, singular, not plural, as a reference to an adapter object. If you go back to the code that I have written here, it is referring to line 8, which is an UI adapter. The UI adapter itself is actually an interface. It is not a class. Okay, if you look at uppercase UI adapter, it is the name of an interface, not that of a class. The purpose of UI adapter, as you can see in this code here, is whenever the value changes in the counter, I am using the adapter and say, hey, adapter or broker, okay, tell whoever needs to be, notified that this counter has been changed already. Now, do we have one single listener, or do we have multiple listeners, or nobody cares about the counter? The model does not care. The model does not know either, okay? Because it is possible, let's say we are dealing with the Costco, counter application. It is possible that you have multiple listeners. The first listener is really just the screen of the app itself, because whoever is clicking it wants to know, the exact number at that point. But you can also have a second listener, which is, handled by the broker. which is updating a number in the actual database in the cloud. So back in headquarters of Costco, somebody can look at the screen of the entire operation and say, oh, I can see that the Rancho Cordova Costco has 612 people within walking into the store within the first half hour. Okay, so that's why you can have one listener, which is just the screen itself. You can have two listeners, which is the screen and also the remote database. Or in some cases, if you choose, you can also have no listener. Okay, it doesn't really make a whole lot of sense to have no listener, but the number of listeners is not really indicated by the UI adapter here. The UI adapter is just a broker. Okay, there's one single broker that may be interacting with multiple listeners. Am I still doing okay so far with these concepts?
So, if you want to have a second listener, you would make the change
I would make a change in the adapter.
in the adapter.
Yeah,
Okay.
in the adapter classes.
Okay.
Yep. But that's the beauty of the whole thing is, I can, if I build a model like this, and initially it is just using the screen to update the number on the screen, and later on I decided, you know what, I also want to update the counter in the cloud so that Costco headquarters know exactly what is the number of people who have walked into a store. This part has no impact whatsoever. It will just do whatever it always does, and there's no impact, at this part of the application. So I have just insulated, changes of one part from other parts of the same application. Is that okay so far? Okay. All right. So getting back to your homework description here. So this is the model itself. Okay. The adapter reference is of an interface type, not of a class type. Okay. So let me go back to my notes, to my own example, to show you what I mean by that. When you look at the type of UI adapter here, which is basically a listener adapter, the more appropriate name is to rename it as listener adapter, because it communicates with listeners. But when you look at the actual UI adapter in uppercase, which is defined, it's inside the package adapter, and it's over here. So if you look at this definition here, you can see that it is not a class. Instead, it is just an interface. It's an interface so that any class that implements update count, returning a void, and have an integer type as a parameter, and also implements register model that takes counter model, in this case, as a type and returning void, any class can fit into this interface. Is that concept okay so far? And I'm not placing any class hierarchy restrictions now in the model class itself, which is great because if I use this as a class instead of an interface, that means an actual UI adapter has to be derived or be a subclass of this particular UI adapter, and that is a very severe limitation, because a class can only have up to one superclass, but it can be implementing any number of interfaces. So whenever possible, I would use an interface to describe the type of something instead of using a superclass to describe the type of something. Is that working out so far or not? So? Okay. So let's go back to this part here. Okay, we'll just leave this one, at the way it is so far, because we'll have another section to talk about the adapter interface itself. Okay, so let's do it here. the listener adapter interface. Okay. The listener adapter interface defines what a class needs to implement in order to become a listener adapter. Okay? Just like in my own code here, it describes what methods are required in order to be qualified as a user interface adapter in my particular case. Okay? So in your case, you will have to list all the methods that are required in order to become a listener adapter in your model, water model application. All right, so let's take a look at our picture again, and then we'll try to figure out what type of methods will be required. This is our state machine diagram. We can see that we can go from water to steam, we can go from steam to water, water to ice, ice back to water, and so on and so forth. Every time we perform a state change, a listener may want to know, okay, oh, okay, water just turned into steam at this point. So the question now is, what kind of interface, what type of method do we want to use in order to notify our listener and say, hey, you know what? I know you're interested in the current state of the water, and it has just changed. Okay. Well, just knowing that it has changed is not enough, right? We want to know how it has changed. Is that making any sense? Okay. So we have a few choices here. How are we going to implement that? Okay, first of all, let me just describe here. This interface needs to define methods that will be used to notify listeners of state changes in the model. Okay. Now there are several ways to notify a listener of the state changes. Okay, so there are two options. Okay. There are two obvious options. The first option is to use one method for each state. Okay, so what do I mean by one method for each state? Let's go back to the picture here. When you look at this picture, you can see that there are really only three possible actions, one corresponding to each state. One action is called, no, I take it back, there are four possible actions. One action is called condense. It goes from water to steam. One action is called boil. It goes from, oops, take it back. No, never mind. One is called condense. It goes from steam to water. One is called boil. It goes from water to steam. One is called freeze. It goes from water to ice. One is called thaw. It goes from ice back to water. So if you want to do it this way, then you end up with four methods. So let me just make it clear. One method for each action. Using this method, using this approach. I don't want to use the word method because method has a very specific meaning in object-oriented programming. Using this approach, this interface will end up with four methods. The four methods will be the following. I'm going to use this notation here, so just so that it's easy to read. You will end up with a void boil with no parameter. You end up with condense with no parameter. You will have freeze with no parameter, and you will have thaw with no parameter. This is one way to do it. Are we still doing okay so far with this approach? Okay, so instead of what I have here, which is update count, you will end up with you'll end up with four possible. You will end up with four methods: boil, condense, freeze, or thaw. That's one way to do it. There's another way to do it. The other way to do it is to use one single method with a parameter. And the parameter itself would use an integer to specify what is the new state. What am I transitioning into? So you can say I'm transitioning into ice, I'm transitioning into water, or I'm transitioning into steam. So that's the other method. I'm going to describe it here also. Okay. The second option is to use a single method for all the actions. Using this approach, this interface ends up with the following method. And this method is returning a void because all it is doing is to notify someone what is the new state of water. And the method will be a new state with an integer as a parameter. You will need to define integers to represent each state. And there are 3 possible states. The 3 possible states are water. Okay, we'll just say state water, state steam, and state, what is the last one? Ice. And these states, or these integers can be defined as a part of the interface. Instead of being defined inside a class, you can have these defined inside an interface. Okay? Does anyone remember we talked about the restrictions of defining integers or constants inside an interface? You can do it, but there are restrictions. Does anyone remember any of those restrictions? It has to be static. It has to be static. Because everything that fits a particular interface has to share all of those definitions. Okay? So they must be static. So to define anything that is static, I'm just giving you an example here. You basically have to say it has to be public because whatever is using this interface has to be able to refer to these constants. So each one has to be public. And then you can specify public, static, int, and then we can say state, ice, and then give it an initialization to 0, and that will work. Okay, so you need one definition for each state. So you have state ice, state water, and state steam as 3 static definitions. And then throughout, okay, whoever is going to use the adapter, now have to refer to these constants. You can also have these constants defined somewhere else, but they all have to be public, so that you can refer to these constants. Now, where would be a good place to define these constants? It's kind of hard to say. You can define these constants in the model as well. Okay, so you can refer to the model, but that means whoever wants to refer to these constants also need to know the existence of the model, which may or may not be the best thing to do. So personally, I would prefer to use the other approach. Personally, I would prefer to use this particular approach because it is an action. It is just reflecting. Okay, water is boiling, or steam is condensing, water is freezing, or ice is thawing. Okay, I think that is a better approach than to reflect the new state, which is kind of less direct in many ways. Are we still doing okay so far with the homework assignment?
So it would be within the model that these are implemented, right? But in terms of
No, this is not implementing the model. This is defining the interface of the listener adapter. Okay. Let's draw some pictures. We start with a model, right? That's the first thing we do. The reason why we started up with a model first is because the state diagram, or the state machine diagram, describes the behavior of the model And as a result, we can start with that one. Is that okay? Now, inside the model, we have at least two private members. One is to store the current state of water. The other one, has a reference to a listener adapter. Okay. So this one, basically is a reference to what we call a listener adapter. Okay, so let's go to the listener adapter here. So this is my listener adapter. When you look at the word adapter, you can kind of, think of a broker. Okay, when you buy a house, okay, people do, but very seldom that a buyer will interact directly with a seller, right? So what kind of people do you use in between when you try to purchase a new house?
Broker.
A broker, exactly. So what is the function of the broker?
Facilitate the transaction.
Facilitate the transaction. And why do we need a broker? Why don't you and I, arrange, to purchase and sell houses directly?
License.
Okay, there's licensing involved. Okay, but what else?
We don't argue.
So we don't argue. Okay.
Oh.
Say again?
Way to do it, or one way to do it.
Well, there are several reasons why, right? But one of the reasons is, one of the practical reasons, okay, it's not legal, it's not, anything else. It's for practical reasons. Do you guys work? Some of you work, right? Do you guys take classes? You are in one right now, right? So that means, if you buy a house from somebody else, that person, okay, can also be working, taking classes, have other things going on in life. Okay, is that making any sense? What about a broker? Well, sure enough, a broker has a job too. But what is the job of a broker?
Takes the responsibility.
To take the responsibility, but more practically, to work with you according to your schedule. So your broker will basically say, okay, I'll work around your time frame. Okay, if you're in class on Mondays and Wednesdays in the morning from 9 to noon, I'll work around that time. Okay, maybe I'll wait for you, at 1 o'clock. Okay, for you to go see a new house or to sign the contract or whatever, right? On the other side, if you're buying a house, okay, if you are buying a house, the seller has the same situation. The seller has a job, 9 to 5, and all that stuff going on. So the seller's own broker would also work around the schedule of the seller. Now the two brokers, now it is up to them to meet up with each other, hash out the details, and work on all the paperwork. But that's their job, right? It is not your responsibility anymore to try to schedule for a time directly with the seller to arrange for time to meet up, time to do the house inspection, and all kinds of stuff like that. Okay, it's the same thing here. Okay, a listener adapter is basically a broker to say, well, if the model needs to do something to anyone who's interested in the current state of water, go through the broker. Okay, so the model doesn't have to deal with it. Is that okay so far? Because the model's only job, the real job of the model, is really to implement the business logic, not to have to deal with, okay, how many people are interested in this water state? Should I do a screen update? Should I, announce the state change using, synthesized voices? Should I update, on a remote server? Should I update a website? Okay, well, it's not the job of the model to do it. Okay, it is the job of a listener to do that. But to manage, all those listeners and keep them all up to date is the job of an adapter. Is that kind of concept okay so far? Okay. But this is an interface, not a class. So this way we can redesign, the classes that implements this interface, all day long, make it as fancy as possible, make it as simple as possible. The model doesn't need to know. In other words, I can make a listener. So we now have a listener. This is an interface. This is a class. Okay. So the listener class can be very simple. In other words, if you want it to be as simple as possible, you can say, oh, okay, since I don't have a whole lot of time, I'm going to make my listener only be able to deal with one listener at a time, or the adapter. Okay, this is the adapter, but it's a class. This is actually implementing that. Okay, you can make it very simple and say, I can only keep track of one listener at a time. Okay, so you can tell me that you want to update the screen. You can tell me that I want to update that website over there, put a little snow picture on it. You can tell me that I can update, let's say, a Google document, okay, to say, okay, it is snowing now, put a log entry into it. But I can only do one thing at a time. Or when you have time, you can expand the listener adapter and say, I can now keep track of any number of listeners. I can do the screen update and update the remote website at the same time. Just register additional listeners and I'm good. So now, but whatever you do with this class now has absolutely nothing to do with this part of the program anymore. The model doesn't need to know, that it doesn't care, how fancy the listener adapter is. Is that okay so far? Now, even if you're not going off device, even if you're only using the device itself, there can still be any number of listeners, okay? Because you can have a listener that has a notification. In other words, when there is a state change, it will beep you or it will play a ringtone depending on the state change. Okay, if it is freezing, it can give you the sound of ice cracking, right? If it is turning into water, it can give you the sound of water running. If it is turning into steam, if it's boiling, it can give you the whistle of a kettle when water is boiling. But that can be a listener that is completely independent to the actual user interface, to the screen itself. Okay? So are there any questions about the rationale behind these multiple layers? No questions? Now, in this case, because this is an interface, I would name it, accordingly. So you might want to, add, interface, as a part of the name, or, just do something so that it is clear to you that this is the name of an interface and not that of a class. Okay. I'm going to write it down here too. Name the interface appropriately, so that the name itself implies this is an interface and not a class. Okay.
Going back to my question, so the model itself knows about the transitions, or does it not know about the transitions? Does it know how it should behave? The H2O should behave?
Yes, it does.
Okay.
Yep.
So shouldn't these, so from the model's perspective, from the users of the models, or in this case, I guess it's the listener adapter, it doesn't have to know that if it's greater than 100 degree, the state of the model have to change to steam, right?
Can you repeat that question, please?
Okay. So in terms of encapsulating the model of the H2O,
To encapsulate the quote-unquote business logic of how water behaves.
yeah,
Right.
right. That is all the details of the models.
Yes, that is
Right.
that will be implemented. The logic will be inside the methods of the model class.
Okay, and then so these transitions to
These are not transitions. These are actions or notification actions. In other words, okay, the model says, okay, something has changed. Okay,
Right.
so internal to the model, it can do everything that it needs to do. Right?
Right.
It can update its own internal state. It can update the current temperature and stuff like that. But how does the rest of the world know about all those changes? In other words, until you say you can do all the changes that you want inside the model class itself, but it is not going to be useful for the application until you have a way to say, hey, all you listeners out there, okay, I just changed the state from water to ice. Do whatever you guys need to do. It may be nothing, but maybe you want to do something. I'm just telling you that water has now turned into ice. Okay? So that's what these methods are for, as an adapter. These methods are basically for notifying whoever is listening to this particular model and say, oh, you know what? Water is boiling. Okay? It just changed from some temperature below 100 degrees Celsius to at least 100 degrees Celsius. Now, it is possible that nobody cares. Okay? None of the listener is saying, oh, okay, boil is fine. I don't need to do anything. Or it might have to do something. Maybe on your screen it will change the color of the background. Maybe it has to give you a notification or notifying tone as a ringtone. Maybe it will send an email to you. Maybe it will just text you, or maybe it will update a variable stored on a remote server somewhere. We don't know. I mean, the model doesn't know what to do. It doesn't care either. It is just saying, I know the water is now boiling, and I'm letting you know. That's it. So the letting you know part is what the adapter or the listener adapter needs to implement, because that is the only way for the model to communicate with the external world. Because otherwise, everything is internal to the class, and it can do all the updates. It can have super complicated logic to do all the updates and the logic, but nobody knows about the update.
So these are methods within the adapter that
Within the adapter.
model invokes to tell all the listener what's happening.
It is just like in this case, when I increment a counter, the action of incrementing the counter or this method is triggered when somebody pushes a button or if someone jerks the cell phone in a certain way, okay? And the model doesn't know what action or what user interaction will trigger the increment. It can be coming from the Costco server itself, okay? But we don't care. I mean, the model is just saying, this is a counter, it can increment, it can reset, okay? But how these actions are triggered is up to the model adapter to deal with it, and we'll talk about that later, okay? But when there is a request to increment, the first thing it will do is to change its internal state, okay? Because I call this the internal state because you can see that value on line 7 is a private instance variable, which means this variable can update all day long, but nobody would know anything about all those changes because it is internal to this class. Even the subclass of counter does not know that value has changed because it is private. If it's protected, even a subclass can know about it, but since it's private, nobody else is going to know about it. So what are we going to do? Well, we're going to let the world know about the value change by using the UI adapter, which is basically our listener adapter. The new quote-unquote name is the listener adapter. So the listener adapter is going to invoke a method called update count in this particular case and say, hey, whoever needs to know about the state of this counter, it has just changed. The new value is da-da-da.
Can you go to the UI adapter?
Hmm?
Can you go to the UI adapter?
Absolutely. So let's go to UI adapter as an interface. Line 6 is introduced here just so that I can show you the syntax of defining a static constant. So that's not originally here. So we'll just make sure that we get rid of this one. This is the original UI adapter. So the UI adapter is really just describing an interface. It's not a class, it is an interface. It is simply saying who can be a UI adapter. And this is saying any class that implements a void method called update count that takes an integer parameter, and also anything that implements register model having a counter model as a type of the parameter and returning a void. As long as a class has these two methods, you know what? I can see those as UI adapters. And that's what the interface is about. Yep, go ahead.
What would be the advantage of having the interface and not just using the class directly?
Okay, because if you do it this way, you can implement different classes and still have those other classes to fit into the UI adapter thing.
It makes it universal, right? So
You make it more universal. I understand your question. Let me try to give you an example. Okay, just I'll use the whiteboard for this purpose. Okay, so let's say we have a class here, and we'll call this class A, and it inherits from another class. So when you inherit from another class, you can say class A extends. No, extension applies to interfaces.
Implement.
Implement.
It's for
No,
interface.
implements
Extends.
to interface extends
Yes.
to a
What
class,
you
to a
can do
super
yeah.
class. So it is it extends
Yeah.
for subclasses?
Yes.
Okay. So let's say this one extends a superclass S, and it has some definitions. Okay. And okay, let me.
Oh, I think it's implements, right?
No, implements.
No,
for
No,
interface.
implements an interface. A class implements an interface, but a subclass what a superclass.
It's like class A extend that exist.
I think it is extend.
Yeah, because
Yeah,
the
it's
pub class main activity extends activity.
Okay, so it is extend. Okay, so it extends a superclass as. So what you're asking is why can't we turn UI adapter into a superclass, and then when we derive any subclass out of the superclass, then it will also fit into that slot.
Not exactly. I'm wondering if we only have one class that implements the adapter, right? Or more than one?
Currently, yes. But it doesn't mean that in the future we will not have another class to implement the listener. The purpose is if I want to change the class to implement the listener, or if I want alternatives, I don't want to make any changes to this side at all. Because once I have the adapter interface defined, then this part of the program does not need to change at all. I can change everything later on. I can re-implement my listener adapter class, extend it, make it very fancy, make it very simple, but that would have zero impact to this side. I can also, at runtime, I can change the listener of this model at runtime using a different listener adapter object at runtime, and it will still have zero impact to this code. But if I use the other method, then I'll be tied in. Excuse me. Excuse me. I'll be tied into a particular class hierarchy, which places a lot of restrictions to what a class can inherit from. Is that okay? Okay. Because the register, if I go back to the model itself, this particular method here, okay, this is really the key part of why we use interfaces instead of classes. This can be called at runtime. In other words, even when the model is up and running, in other words, we have been tracking water molecules, for a while already. At one point, depending on the logic of the entire application, I can change the listener adapter to something else. Okay, maybe it is just dealing with a single listener at one point, and now I want to make it a multicast, which means I wanted to have multiple listeners. I can call this method again, give it a different object, and the object is of an entirely different class at runtime. But since UI adapter itself in uppercase UI is only an interface, it's okay. As long as this object U implements the two things that the interface specifies, it will still be okay. I can refer to that object. It has no restrictions as far as inheritance class hierarchy is concerned. Is that making that point? Okay, not having a superclass restriction opens up all kinds of possibilities.
What does the set UI adapter do?
That's all it does. This is the actual code. It updates the variable up here. This is my a reference, an interface reference to a lowercase UI adapter. In other words, it's just a way for me to keep track of who's my broker. This method allows you to change your broker halfway through the execution of this program. Now, why you want to change your broker halfway through, I cannot think of a reason for this particular application, but for certain other applications, maybe there are reasons you might want to change your broker or the load adapter halfway through. But this at least gives you the option. You may never need to do that, but it does give you that option. But the most important part is this code, once it's done and debugged, I can just leave it alone. I can make everything else about this application, I can change everything else, make it more fancy, make it more flexible, but this part is done, because it is now insulated from the rest of the program. Is that okay or not? Because I know these topics are fairly, can be a little bit abstract because we are doing things seemingly with more layers and more trouble than it's worth, okay? Because remember, with the counter example, okay, that's funny, counter example.
Not the counter.
In mathematics, counter example has a very specific meaning, to prove something wrong, right? Counter example.
Oh.
Well, since I'm teaching cisp300, that term just pops up in my mind, because I use that term a lot in that class. But in this instance, it is just saying, okay, this is sample code using counter as an application, right? But in this particular application, it's really simple. You remember that I re-implemented, simple counter right here, and put the entire program, every single piece of logic, into a single class. It could have been done just like this. But this will make the application extremely fragile, okay? Or I call it brittle, because anything that you try to work on one thing, you try to make some changes to this one, everything has to change at the same time, okay? Whereas the other one is modular, okay? You can make changes to one part with zero impact to the other parts, which is what we want to do when we have larger projects. With small projects, it doesn't seem to make any sense. But when you have a project that is, thousands or tens of thousands of lines, then it suddenly starts to make sense that you want the program to be flexible enough that you can make changes to one part with zero impact to the other parts. And that has to do with a lot of planning. You have to plan ahead of time, which is what we're trying to do here with this homework assignment. Yep.
Can you go back to the last screen you're on?
The last screen. You mean the browser?
No, the main activity, I think.
The main. Oh, you mean with counter?
Yeah, whatever you're just on. Counter activity, but you don't remember.
I think it was the model.
Yeah, so on set UI adapter, if you're passing in UI adapter, how does that change? How can you change it to a different adapter if it's the same name? Or that's an interface, right?
That's an
How do you
interface.
change it to a different interface if it's the same name? Okay, so in this class, it says
Okay.
private UI adapter, UI adapter.
Okay, I think this example will illustrate what you're asking. Okay, so let's say I have an interface. I'll just call this I, blah blah blah. Okay. So I have an interface called I, and now I have a class C1, which is extends S1, which is a superclass, and it implements interface I. Yeah, do some definitions here. Okay, so C1 is just a subclass of S1, and C1 can implement interface I. It meets all the requirements specified by the interface I. Interface I, only has to specify methods and say that, okay, I'm expecting, these methods, and each one has a particular return type and also a list of parameters. As long as class C1, either through inheritance or its own extension, implements those methods, you know what? Yes, we can implement interface I. Good. So let's go for another example here. Okay, we have class C2, which is also a subclass, but this one is out of an entirely different inheritance tree. Okay, this one extends S2, and S1 and S2 do not share any common ancestry, other than just Java language object itself. Okay. But since since C2 also implements whatever method is required from the interface, it can implement I as well. Is that okay? So these are just three definitions. The details don't even matter in this case. Okay. So now, just trying to find a place. I can just reuse this part here. Okay. Okay. So now, if I have a variable, okay, it can be a variable inside the method, it can be a class variable. It doesn't really matter. But if the type of the variable is of I, the interface I, okay, so let's say this is I here, then I can, in one statement, I can say I is new C1. This is okay.
So that's an I and then a semicolon.
This is I as in this one. Okay. How about
Okay.
fine. Okay. This is okay, because as long as the object implements this particular interface I, this assignment is fine, not a problem. Now, but after this assignment statement, I can only know this object as something that can implement this particular interface. I lose all the details about that particular class. Is that okay? But in the next statement, I can say at a later point, if it is necessary, I can now say K is new C2 in parentheses. That is perfectly okay, because both class C1 and class C2 implements the interface I. So objects that I create out of these two classes, they either can become, the reference to an interface I can refer to those objects.
It's sort of like saying that what are the commonality between different classes?
Correct. Or more like, I see it more like a filter. What is the qualification to fit this interface? So you look at the interface like a funnel, like a filter, and you're basically saying, okay, what classes can be seen as something that implements this interface? And in this case, this is a good illustration because it really shows you that C1 and C2 can be completely unrelated. They don't share any superclass at all in the inheritance tree, but as long as they implement whatever methods are specified in interface I, it's still okay. Not a problem. Because the other way to do something like this is to use the concept of a superclass. Okay? If I is a superclass and it is in the ancestry of C1 and C2, this can happen too. But then I'll be placing a very expensive restriction on the class hierarchy, because one class can only have up to one superclass. And if I use up that one superclass just because I want to be able to do this, then I have lost the ability to use the superclass for anything else. So that's why whenever it is possible, using an interface as a type of a reference to something else is always preferred to using a superclass instead. This is a big deviation from C++. For those of you who know C++ or have taken object-oriented programming in C++, you'll be using superclasses for this purpose, which is okay, because C++ has multiple inheritance, but this is actually a much cleaner way to do things, from many perspectives. So are we still doing okay here? You know, have I kind of explained why I'm using an interface, going through all the trouble to define an interface first before I define classes that implements the interface? All right. But this code, you know, since we're here already, it is also useful to illustrate how are we actually using UI adapter as a member variable. Well, this is how we use it. Okay. In the case of a counter, whenever we change the value, which is the state of a counter, we need to let the world know about the change. So the adapter, the UI adapter here, which you should rename as listener adapter, its only job is a broker and say, okay, I want to buy a house up to this price range here. Let potential sellers know about it. Well, I'm not going to deal with all the potential sellers out there. My broker is. So the UI adapter or your listener adapter is your broker. When you change your mind and say, oh, you know what, I just lost a whole bunch of money in a casino, so now I can only afford a house up to $100,000. That's a state change on your part, right? But how do you let all the potential seller know that you can no longer afford a $500,000 house? Well, the broker is going to do it. Okay, so that's what this little variable is for. UI adapter is your broker. Is that making any sense so far? Okay.
This is sort of slightly off, a little bit off topic. I was wondering if you want to change in Eclipse, if you want to change the name of the interface, is it very straightforward?
I have not tried that. Well, this is a good place to try it. Let me see if I can do a right click. And this is a replace. Okay, that has nothing to do with it. That's not changing it. References. Nope. I don't think there's any easy way to do it. The only way to do it that I can think of is really just to define a new one and then change the rest of the code. There's no easy way to just replace it.
That's unfortunate, because there are. I could easily think there's frequently that you decide that a class like changes its functionality, and you might want to change the name to reflect the change in functionality or whatever.
Well, this is the price that I pay for not thinking ahead of time.
Well, it happens very often.
It happens often, so that's but that's a consequence, for developers to learn from, in order to say, okay, in order to avoid having to make all those changes, this time I'm going to think way ahead of time to plan, okay, how should I name this particular interface? Because when I name it user UI interface or UI adapter, I did not think of what if the adapter is talking to someone who is not a part of a user interface? What if it is talking to a website, updating a particular page or a particular entry in a database, adding a line to a log and stuff like that? It's not a user interface, right? But it is a listener because it is somebody who's interested in the state of the counter. Okay, so that's why, well, listener is a much better name because it doesn't describe what the listener is going to do about the change. It just says, okay, that person or that object is interested in this model, state change, but we have no idea what it wants to do once it knows about the state change. Okay, so let's go ahead and kind of continue with this one. Yep.
Another just quick question, but in terms of, is there a convention, coding convention for the naming of the interface?
I cannot find one.
Because when I look at your counter example, right, it would have been nice if the name of the interface has an I or something at the end, so I could easily know that's an interface.
Okay, so here's Stack Overflow. I try not to go for a Stack Overflow if it is possible, because Stack Overflow is still based on opinions from people. So if I can find a more definitive source, that would be better. And
Java practices.
Yeah, we can do that, and then we look for.
Because
there a
interface.
function that will let you search and replace all?
No, but it looks like, you know, an interface starts with the uppercase I is the convention, and regular classes do not start with the uppercase I. But what if the name of the class itself starts with the uppercase I?
You have two eyes.
Then you have,
You have two eyes.
Then you have two I's.
I.
You have I. Captain. It's still not. It's still ambiguous. You know, it still doesn't give me that, you know, feeling of, you know, oh, yeah, this is the way that will resolve everything. Because if a class also has a prefix like a C, then we know for sure. If it starts with a C, it's a class. If it starts with the I, it is an interface. And I think the lack of a C as a prefix of a class has to do with interface was an add-on feature. So they did not think of, oh, okay, you know, interfaces are different, you know. But you can certainly use I as a prefix, you know.
Maybe like an I underscore.
I underscore, or I face, you know, IF, you know. Just use something that is a little bit more distinct than just the uppercase letter I. Yep. All right, so that was a good question. You know, I was a little bit curious about that as well myself. All right. So that means, you know, okay, so this part, I'm going to write it down too, okay? Some conventions start the name of an interface with the uppercase I.
It's also the same convention used in COM programming.
Right, COM programming definitely has a much stronger convention, I think.
Because they use the I, the capital I.
Oh, they use the capital I too? Oh,
Yeah.
okay.
What program is that?
COM programming has, it's mostly a Microsoft methodology.
But they use interfaces like this.
Yeah, okay, COM programming, you know, to answer his question, because it's component object model, which is, you know, another type of model for development. And it also makes use of classes, interfaces, and so on. Okay, that's good. I think who came up with COM? I think it was Microsoft, isn't it? Yeah. COM programming is interesting because it is it's a way. It provides a mechanism where a program can be broken up into parts where one part of a program runs on one machine and the other part runs on the remote machine. COM was designed specifically to allow that to happen. The only reason why I know about this has to do with GPS. Some of the GPS companies, they allow people to use an API to talk to a remote machine to do, you know, not GPS, GIS type of application. But since they don't want to release the code in any form to people who are actually using the GIS system, they basically run the code remotely on another machine. So there's no way for anyone to quote-unquote reverse engineer the actual code anymore. Am I making any sense? Okay, if you install a program, okay, that program is going to sit on your hard drive, right? So as long as that program is sitting on your hard drive, you have access to the object code or the machine code of that particular program, and with enough time, enough people, you know, you can actually decipher the object code of the program and figure out, you know, how it does things and reverse engineer the product. So what some of these companies are doing is they run the code or the library part of the code remotely on another machine. So now that you have no access to the object code whatsoever, it becomes virtually impossible to reverse engineer the product. And COM, C-O-M, you know, allows that to happen. You know, that's actually part of its design, you know, objectives.
But at a factor of possible performance.
That is correct. You are going to pay not only performance but also reliability, because now you need constant network access in order for the application to run. But it is not uncommon for some of the more sensitive type of libraries to be implemented this way. But it also has, it also opens up possibility to improve performance, because how fast can your machine run when it comes to really heavy duty type of rendering or physics simulation? Probably not as fast as a data center, right? But using the COM model, your quote unquote subroutines are not being run on your own machine. It is now being sent as a request to potentially a huge cluster of servers, that will run your whatever subroutine you're requesting and come back with a result. So it can go both ways in terms of performance. But it is a good abstraction, because it serializes everything. All right. Do we have any questions at this point? It looks like we don't have enough time today to really finish the entire thing. But I'm gonna go, and try to finish a little bit more, just a little bit more. Looking at this code here, do you guys have a good idea of, what your code will look like for the H2O model? It's going to be a little bit more complicated because in your case, you will need conditional statements. Because you need conditional statements to implement the guard conditions. Okay. The other thing is it's going to be a little bit more complicated because in this case there's only one update. Okay, there's only one thing that a listener needs to know is, okay, what is the new value of this counter? That's all that it needs to know. In your case, depending on which way you want to implement it, you can have the 4 methods corresponding to melting or thawing, boiling, condensing, and freezing. So you can potentially have 4 methods depending on the conditions. You will have to trigger those methods. And those methods will belong to which variable in your application? Freeze, thaw, boil, and condense.
Repeat your question again?
Okay. You remember that there are 4 methods that, okay, this is actually giving away the solution already. The 4 methods, okay, boil, condense, freeze, and thaw. Those methods belong to who? The listener adapter, right? And in this code with the counter, what is the counterpart here that is your listener adapter? It's called a UI adapter in this program. Okay, so that means whenever I call update count here, those would be the places where you need to call one of those 4. Okay, but you cannot just call them because in this case, every time I increment, every time there's an external trigger to increment the counter, I am going to do this without any conditions because that's just the way that a counter works. There's no guard condition whatsoever. But in your case, you have guard conditions. So you need to figure out how to use conditional statements to implement the guard conditions. You also need to look at your current state to find out whether you're already in the state and the transition is not going to transition into another state. If you go back to the diagram, or if you recall from the diagram, does it say anything about a transition back to itself? In other words, if my water is just getting a little warmer, okay, if I go from 25 degrees Celsius to 30 degrees Celsius, does that trigger a state change? Is there a transition associated with that temperature change? So that means you will have to figure out how not to trigger a transition when the temperature is changing, but it's not triggering a phase change. Phase as in PHASE, phase change, or state change. So you will have to kind of figure that out. So your model is a little bit more complicated than the one that is described here. Any questions about that part?
When does this due?
Oh, it's going to be at least 2 weeks because I'm not even done describing what you have to do. This is really just the model part. We touched on the listener adapter interface part, and I haven't even started on the listener adapter class itself, or the class that can implement the listener adapter. But all of those will be parallel to what I have done here with the counter example. So you can basically look at the counter example, and at least I wouldn't do any real actual coding except for the model part, because the rest I have not described yet. But you probably want to identify the different parts of the counter example and understand what each piece is doing and how it connects to the other pieces. So that would be something that you can do before next Monday, so that by next Monday we can finish up the description of what you have to do with this project. I would turn this into a project because it is definitely a lot more involved than a single homework assignment, and I'll use it for your in place of your first exam. I'm going to turn this into a project. So are there any questions? The main objective is really just to let everyone be aware of this way of looking at things, because the worst thing about being a developer is being impatient. Okay, I know how to do this, and I would use the shortest route to do it. The shortest route is okay. You will turn out the product real soon, but the problem has to do with maintenance. Okay, what if somebody wants something else? Well, I can add some more code to it. I can add some more code to it. I can add some more code to it, and then before long, what do you get?
Mess.
A big old mess. Exactly. And the bigger the mess, the more brittle the code becomes, because the more difficult it is to attach additional code, but without causing problems. So that's why this type of engineering or software engineering approach is very important, because it helps to make your program extendable in the future without paying the price later on.
It takes a lot more time though.
Sorry?
It takes a lot more time to engineer.
It takes a lot more time to plan. That is correct. It's kind of like building a house. Okay, if you try to build a house and you're hasty and you just go buy 2x4s and 4x4s and all the material, and then you start putting things together. Later on, you might say, "Oh, okay, I just made a mistake here," or "I want to do something." Okay, classic example. Okay, you do everything. Let's say you have a concrete slab. Okay. And you didn't quite plan, well enough to allow for certain things to happen. And then one day you just say, you know what, I want to route the hot water to this part of the house. Well, if you did not plan for that and you have a concrete slab and your water pipe is there, well, there's no easy way to do it anymore, right? You have to open it up, dig up the concrete, get to the pipe, and then extend it. So that's the same thing, with software development. Is you don't want to kind of paint yourself to a corner, and so you have to do all kinds of stuff just to get around a particular problem. It kind of comes with experience too. You just have to learn by experience. It sounds like you have some experience with larger scale type of programming. A little, not much.
These refactors takes a long time.
Hmm?
These usually refactors, kind of engineer a little bit, and then code, and then refactor as you go along.
There are different models. What you're describing is what we call the Rapid Application Development Model, or the RAD model. The RAD model lends itself to getting a prototype out really, really fast by comparison to a conventional, what we call waterfall model. A waterfall model means until you're completely done with phase 1 of the planning stage, you do not proceed to phase 2. You wait. You get everything done, and then you move on to phase 2. And then once you're in phase 2, you finish everything you have to do in phase 2 before you move on to phase 3. RAD basically says, okay, we'll do some part of phase 1, and then we'll move on to phase 2, and then we'll move on to phase 3, and then sometimes we have to go back to revise something, and then have the changes to repropagate again. Which works okay sometimes, but it also has a potential danger of getting yourself into a situation where, oh, I can't really make any changes easily anymore.
How's that different from Agile?
Say again?
I've heard of Agile.
Agile development?
Yeah.
I have heard of it, but I have not studied it.
I think it's incremental.
It's incremental?
Just small rapid changes, I think.
Small rapid changes still require a structure that supports the small and rapid changes. Without a structure, small rapid changes can easily make the product unmaintainable, in a very short amount of time.
The product still has an Agile still has an overarching design. It's just you don't make up the firm concrete details until you come to the part that you're developing.
Can you speak up?
Agile still has a overall arching design and philosophy behind the big ideas. It's just you don't. So say that this week you're working on the UI, you don't design the fine details of the UI until you actually start working on it. Instead of spending the entire upfront part designing every little bit about everything. So you don't design the UI, the models, the state bases, all that. You go, I'm working on states this week. Let's design the states, work on them. Okay, we're working on UI this week. Design the UIs, work on them.
You break them up in smaller tasks so that you can accomplish this task quickly, or relatively quickly, I guess.
The other name is also called, it's basically an incremental development method. So I'm just quickly reading through this part here and see if I can give you a quick summary. So-called lightweight agile development, software development method evolved in the mid-90s as a reaction against the heavyweight waterfall-oriented method, which is basically, okay, you do not proceed with anything else until your foundation is done. Okay, and then you move on to the next stage, and then the next stage. You do not go back. Okay, with the waterfall model, the intention is do not have to go back to an earlier stage. Okay, you keep moving forward, so you don't move forward until you're ready to move forward.
It's very much enterprise, practice rather than I think.
Right, but it also, create problems of, a lot of times, the earlier phases will be so involved that people run out of money just because, of the first or second phase. Then you don't get a system at all. You get nothing out of the whole thing. Whereas, Agile says, okay, let's prioritize. Okay, we will plan out and say eventually we want all of these things, but we'll prioritize. These things are more important. These features are more important. We'll focus on getting those things rolled out first. Okay, and then we go back and then we'll do some more additions or modifications to get the other features available. I think that is what the incremental model is really surrounding, is basically the ability to first know what we want from the system, but let's not worry about some of those features and focus on the core features first, and then we can go back and then we can implement and revise it to get all the features done. So I'm just kind of doing a quick reading here. Agile value is individuals and interaction over processes and tools. So it is very much, crowdsourcing is a prime example of Agile, okay? It is all based on individuals, okay? You, I, the whole class, and interaction, okay? In other words, instead of everybody looking at a single blueprint, which is called the system specification, we talk to each other constantly to figure out what is happening, what changes are we making, and what changes do I have to make it happen, and so on and so forth. It's based on interaction. Whereas the other one is centralized control, right? You have a single document called the system specification, and everybody uses that as a reference. You and I do not need to talk at all, because I'm working out of the same documentation, you are working out of the same documentation. I don't need to talk to you because nobody is changing the documentation. That was the premise of the waterfall model. Whereas in Agile, it is all based on, the project is going to flow and change direction and be modified on a daily basis. So we need to talk every single day. Okay, the company needs a half-hour meeting every single day just so that everybody is brought up to date with the current development. Whereas with the waterfall model, nope, you have the blueprint, I can lock you in your room for half a year, get your part done, and then the rest of the team will do exactly the same thing. Working software over comprehensive documentation, which means it is focusing on getting something out the door as early as possible. Okay, it's getting something done. It may not have all the features available. It may not have everything done first, but you get something working out of the door instead of getting nothing, for 15 years. Okay, within the first year, you get something out. Customer collaboration over contract negotiation. So once again, this is based on interaction. Things can change over time instead of, we set everything in stone, okay, concrete. Okay, this is what the contract says. 10 years ago, and this is what we're going by today. Okay, but things have changed. 10 years ago, we don't have tablets, or mobile computing is not even important, and now it is important. I want these newer features. No, the contract says, it's only going to work with a dumb terminal. So this is all the system is going to do. Okay, because the contract says, it only has to work with a dumb terminal. Responding to changes over following a plan, same thing. You're just being more reactive than just following a particular plan. It's not static anymore. So I think these are all basically working together to form the agile development philosophy. It's more like a philosophy than anything else. I mean, it's really just a way of looking at things, okay, or it centers around how to look at things.
It seems like this is more targeted towards startups and stuff like that, but
Yeah.
I would probably say that it is also applicable to larger systems too. If you look at all the failed mega projects that have failed, they all follow the waterfall model. And basically people could not prioritize what is important and say, okay, let's roll something out that can at least get these particular things done, and then we'll add on all the other extra features later. I think the DMV has a project that failed that costed millions of dollars, right? Nobody knows. Does anyone work for the DMV or has worked for the DMV? Okay, we can just look for that
Yeah, I
too.
can transfer from the database to another big loss.
Yeah, DMV failed IT
how about Obamacare?
Obamacare. Are you referring to the website part of it?
Well, I think isn't it a CPI or like a contracting company? I think whatever the name is called. I can't remember.
Okay, so I think let me pump it up. In 1987, the California Department of Motor Vehicles (DMV) hired Tandem, and then the consulting company Ernst and Young replaced its aging mainframes and merged its massive driver's license and vehicle registration databases. 7 years and $44 million later, the DMV threw in the towel, leaving it tracking 50 million vehicle registrations and driver's licenses and 5.2 billion of fees per year using vehicles and driver's license system first written for RCA computers in 1965. These applications currently run on IBM mainframes that have 220 gigabyte database, that have a 220 gigabyte database, and by today's standard, 222 gigabytes is like for an information system. You can buy a 1 terabyte hard drive from Fry's for how much money? $80? They're up to 4 terabytes now. Consumer model are now up to 4 terabytes. So, these projects are very costly, and it took 7 years for the DMV to say, okay, is it gonna fail? Is it gonna fail? Is it gonna fail? And then 7 years later, they said, okay, it's not gonna work. Let's, stop it. Because at that point, if they don't stop it, they'll just be dumping even more money into the project and still get nothing out of it. So Agile is trying to fix these problems by saying, okay, we'll be able to deliver something within the first year or the second year. It may not be the entire product, but we'll have something ready. But the risk that you run, when you use Agile, is it is very dependent on the team. Okay, let's go back to the core value of Agile development. Okay, individuals, working software, okay, individuals, collaboration, and responding to changes. In other words, if you have employees who have been using the waterfall model and do not want to switch to a new way of looking at things, you cannot use Agile at all. It depends on the people a lot. On the other hand, if you have a group of very energetic developers, they are open-minded, they're open to these new concepts, and they work well with each other, then you have a chance of using this methodology. Because you really need a team that work together. Okay, people do not put blames on other people. They're not cutthroat. They don't try to promote to the next level by stepping on other people and so on and so forth. And some environments just do not have people like that. I mean, so Agile is very, you can use it, but there are only certain places or conditions that you can use Agile, and not, you cannot universally and say, okay, we'll use the Agile method.
Well, I see an issue. I mean,
It works well for startup companies, I can tell you that much, especially when it comes to apps, things that are quickly changing. Then it makes a whole lot of sense, because as you're writing applications using API level 19, by the time, if you use the waterfall model, by the time your product is released, it'll be up to API 30. Your application will look ancient by comparison, right? And then the other thing is, if you need a good team of people. For larger organizations, they don't really have a lot of options at that point, because unless you're ready to fire like an entire division of people and rehire people, you have to work with the existing employees. And existing employees may not lend the culture of the company to this type of development. Whereas if you start up a new company, you get to choose, who joined the company to begin with, and as a result, agile development becomes, more of a possibility.
how well does Agile do when there are people coming into the team versus then leaving the team in terms of loss of knowledge on the project?
It is more susceptible to problems, that sort of problem, because with the waterfall model, assuming the blueprint, the system specification was done correctly, then the next person who comes in can just read the system specification, and you can just point out and say, you are responsible for this part of the system. And that person, as long as that person understands UML diagrams and stuff like that, then it's okay. I mean, you can easily replace a particular member of the team. Whereas with Agile, with the Agile approach, stuff is not documented, right? If it's changing, so rapidly, a lot of this stuff may not be documented. So if someone is leaving the company, that person can be taking a lot of the knowledge with him or her and become irreplaceable. So you do have a certain risk associated with Agile, type of programming. I'm just going to quickly go through this, also to Agile principles. Anything that has a manifesto is kind of interesting. The waterfall development model does not have a manifesto. It just says, do as the specification says, right? Customer satisfaction by rapid delivery of useful software. Welcome changing requirements even late in development. Working software is delivered frequently. Working software is the principal measure of progress. Sustainable development, able to maintain a constant pace. Close daily cooperation between business people and developers. See this word here? Daily. Face-to-face conversation is the best form of communication, as opposed to system specification, diagrams. Basically a big, huge binder that says, do not make changes. Has anyone worked for larger organizations or organizations where they can be audited by the government? I have, okay? I worked as a consultant for a company that makes weather equipment, okay? Weather measurement equipment. The project that I was on makes a accelerometer. It measures the height of cloud. But anyway, they have one person who is in charge of document control. They have a room dedicated to document control. In other words, if you want to look up the design of a particular circuit board, okay, you go to that room and you ask the person at the door of that room and say, I want to retrieve document da-da-da-da. That person will go into the back room, retrieve the document, and give you a copy of that document. Now, let's just say that one of the equipment uses a part that is obsoleting. Okay, basically the manufacturers tell you, we are no longer manufacturing this particular integrated circuit. You have to change your design to use something else. Okay, this kind of stuff happens all the time. Okay, You cannot, as an engineer, you cannot just say, oh, okay, I'll start on this project, I'm going to make some changes to this circuit design. You have to go through a whole process to get approved. Now, it is not enforced by the company itself, it is enforced by the U.S. Weather Service, I think, and also the FAA. The FAA in charge of airports and stuff like that, they place constraints on these things. Okay, you cannot just say, oh, you know what, we are now using another part for this component on this circuit board. You cannot just make that change and update your document. Everything has to be controlled. You can see, agile development cannot be used in such an environment because it's not the company itself not wanting to do it. It is the auditing process that basically says, no, if you use agile development, you won't get certified anymore. The government will say, if you don't play by these rules, we cannot use your product. You don't get certified. Face-to-face conversation is the best form of communication. It works up to a certain extent, but personally, I like everything to be written so it can be reviewed later on. Projects are built upon around motivated individuals who should be trusted. Well, I'm not saying that people cannot be trusted, but things happen. Okay, things happen. So people have to leave the company for personal reasons. May not, they may not be defecting, but they have to leave companies, for one reason or another. Continuous attention to technical excellence and good design. That part I can definitely agree to. Simplicity, the art of maximizing the amount of work not done, is essential. The art of maximizing the amount of work not done is essential. Okay. I'm having problems parsing this sentence. The art of maximizing.
You're saying it's essential not to get a lot of work done. And be efficient at it.
So that would seem.
Well, efficiency versus effectiveness.
But simplicity.
Don't load or complicate your design.
But that goes entirely opposite to the whole concept, of MVA and all that stuff. Seems to be opposite to this. Okay.
If that's the simplest solution to the problem, then use it. But if that's more than what you need for the problem, then no.
Mm-hmm. Don't plan too far into the future. The company may not go IPO anyway. Don't start spending the money that you think you'll be making when the company goes public.
Well, that's good advice for everyone.
Say again?
That's good advice for everyone anyways.
Right.
I feel like it's the 80-20 of coding practices, the 80-20 principle.
The 80-20, oh yeah, the 80% can be, the last 20% would use a lot more resources, yep. Mm-hmm.
You haven't saved your changes yet.
Oh, in my homework? Okay, let me save that first. But I do want to kind of finish this discussion because it is interesting, and we don't teach that class anymore. That's the problem, is we don't teach systems analysis anymore, which is typically where that would be the right class to talk about these topics. Self-organizing teams and regular adaptation to changing circumstances. I can tell you one thing or two about self-organizing teams. I used to work for a company in Davis. Cannot name that company, but I used to work for a company, and I was software engineer #1 in that company. I was the first person hired full-time to work on software. So, and I was hired when the company only had 12 people. When I left 8 years later, the company grew to 120 people or so, and the software development team became a team of 8 people, I think. So when I was there, we were operating pretty much using most of these principles. Self-organizing. We use daily, face-to-face communication and stuff like that. As soon as I left, according to people who still worked for the company, problems happened. Okay, the next person who became what I call the software group leader, who's basically just the senior person who knows more about the product, who can serve as a lead and say, okay, we need to go in this direction with this one. This will take probably 2 weeks to do. Let's plan for that. This, on the other hand, it will take only 2 days. Oh, we have to get that done first because the product is already released. We have to patch that software first. So someone who can prioritize things and just basically associate a price tag to each thing that we have to do. And then people just kind of take up the pieces and say, oh, I can do this part, I want to do that part, and so on. And when I was there, the team was operating in that fashion, and that's why they called me one of 7. That's a Borg, designation. Yes, I was actually one of 7. They put it on my nameplate, outside of my cubicle. As soon as I left, the next person who took over the software division was sexually harassing one of the engineers. The other engineers do not want to listen to him because he has, a certain attitude, which I did not observe when I was the group leader. The whole team just kind of fell apart. Some of the older members, the people who were in their 40s at the time, just left because they were so afraid that they would not be able to leave later on and get fired instead. They just bolted. They just go, Tech, can you write me a resume now? So I can leave when you are still, the group leader, and I can get a good resume out of you instead of the next person who may not, do that. So the thing just fell apart. So that's the story that I have to tell you about self-organizing teams. It works sometimes, but it depends a lot on the chemistry of the members of the group. And a lot of times it's the interaction too. You lose one member out of the team, that can change the dynamics of the entire team. So I just want to let you know that, bad things can happen, if you have, self-organizing teams and members, change. Regular adaptation to changing circumstances, that's definitely, a useful philosophy. So I'm not sure, whether you guys, how much you're getting out of this discussion. What do you guys think? Is that stopping anyone from, starting your startup company?
If anything, I think it helps.
Well, it helps to be aware of potential problems. And if you look at the history of Silicon Valley, a lot of times friends turn into enemies. Employees turn into competitors. Typical example: Intel and AMD. The guys who started AMD were Intel employees, and they started AMD to build a better product to compete with Intel. Which is not a bad thing, good for customers. So on paper it is good, but in reality, in practice, it takes a lot of, it has a lot of conditions that has to meet first in order to really use it.
I think you have to keep the team small in order to keep agile development actual, and have good leads.
Correct.
In order to have agile development actually work.
Right. The other thing I can also tell you about agile development is I have taught the MicroMouse design class at UC Davis for years, more than 10 years. And that's one class where the agile principle is actually applied because things happen. Teams have team members have different types of interaction. And I can tell you, using the agile principle, the people becomes really, really, really important. Because in a typical homework assignment, I will be the one specifying, okay, in this homework assignment, you have to do this, that, and whatnot. Okay, and then each one of you will go home and do your own program and do your own development, right? And you can work according to your own pace, and you can take the consequences of your hard work or their lack of. Okay, your good planning or their lack of, and so on. What if you're working in teams? Well, then you have to coordinate, right? You have to collaborate. You have to coordinate. Some people may be taking more classes than other people, okay? And some people may have more exams coming up in the next 2 weeks than some other people. So now you have a lot of factors to adjust to get the team to work. And at UC Davis, what I have found out is the best teams, or the teams that come up with the best product on time, working, filling all the requirements, are what I would call the B teams. The B teams typically consist of students who have a GPA of around a B. Okay, at UC Davis, getting a B as a GPA is not bad. I mean, it's respectable, but it's not really exactly the stellar, geniuses either. The teams that have the geniuses tend to fall apart real fast. Egos, exactly. They all have an idea, they're all energetic, they all want to do things their way because only their way is the only right way. Okay? And those teams fall apart just like that. Okay? A few months into the project, they don't talk to each other anymore. The C team sometimes can still work, okay, because they're just kind of a little bit slower, in terms of keeping up with the paces of the project. But for the most part, they know they are slower, so they just spend more effort, more time, and spend more time with me to try to get something to work. The B teams are more self-reliant. They have the level of knowledge and commitment to get it done, and they don't get into fights either. So that's why they're the best teams. But that really kind of connects to what we just talked about. The team dynamics. You can put a whole bunch of geniuses together to form a team. It may not be their best team either. So this is interesting. It's an interesting discussion. I really kind of enjoyed it, because it kind of helped me recall some of my past experiences with, teamwork and whatnot. The waterfall model, on the other hand, is very rigid. Okay, you have a plan. It is all well documented. No one's going to change it. Nothing can be changed. But you know what? It has one benefit. You can change team members without a whole lot of impact to the overall project. So there are advantages and disadvantages to each one. And if you're starting with a company, you kind of have to blend the two and understand. Okay, sometimes we have to use this approach. Documentation is important. Okay, as much as agile development says, okay, interaction is more important, face-to-face talking is more important, have everything documented. Okay, it's just that you're not saying that things cannot be changed. Document the changes. So now you have the best of both worlds, right? You have the latest document that is changing in the evolving project, but at least it is documented. It's on paper. Okay, everybody can read the document and understand, oh, okay, we are now making changes here, there, and whatnot, or we are changing direction, and so on. So I would say documentation is still extremely important, even if you use the agile development method. All right, so
I look it up to search on how to rename a class or interface. If you right click on and go to refactor, and then there's an option to rename.
Oh, okay. Refactor.
Yeah, and then there's rename. And then it'll look for all instances of that name and then
There
rename.
had to be something in there like that.
All right, let's try it. And it shows you all the places where the names have to be changed. Nice.
Because it couldn't have been that hard to do, right? It couldn't have been that hard to do. Just look through all the files with that exact name.
That's why we have sed and VI.
Yeah.
Regular expression is good for this type of thing. Yeah. Do you know what is sed? SED? It's called a stream editor. So you can do everything that VI can, except you can pipe a file into it and then pipe the result back into a new file. So you can make changes like that. But it's not aware of the syntax of a programming language. So occasionally it would do things that that would actually break the program. Oh, thank you. That's a good discovery.
What does refractor mean?
Refactor or refractor?
Whatever that said.
Refactor. It's changing the infrastructure of the program, basically. Extract interfaces or extract interface is interesting because what it's doing is the tool is going through your class definitions. And it will say, you know what? These classes all implement these specific methods. Would you want to consider turning, making an interface that these classes can implement? It will do it automatically. That's taking a lot of fun working out of software development. This is certainly something that will only apply in an agile development cycle, because according to the waterfall model, if the original state diagram or the class, not state diagram, but the class diagram does not have a superclass for these things, you cannot make a superclass for those things. And this is basically saying, you know what? I can look at all my classes and see if they share something common, and I can turn that into a superclass. And not only the tool is helping you identify and say class A, B, and C, they all share certain methods and certain data members, and you can turn it into a superclass. If you click yes and finish, it will actually create the new superclass for you, and then change the class definitions to make use of the new superclass. So now the subclasses do not have to duplicate all those definitions. That's what refactor is going to do. Yep.
How intelligent is it? Does it have to have the same names, or does it kind of just know the general?
It analyzes. It's definitely computer language aware, because that's the only way you can actually check the parameter list and also the return type to make sure they match. And also public versus private versus protected. They all have to match in order to make a superclass or an interface out of something. Yep. It's good when you have, these are definitely tools intended for agile development. Basically, you keep developing, you keep developing, you keep developing. People copy and paste, copy and paste, and copy and paste. At some point, the program has so much duplicated code that you go, okay, hold on a second here. This is not good. Okay, we have all these duplicate method definitions, all these duplicate class variables defined, and this tool allows you to quote unquote clean it up automated way. And that's basically what refactor is doing. It's optimizing the infrastructure of your classes, interfaces, and stuff like that, so that your program is as clean as possible or as elegant as possible. It's a way. I look at this as this reminds me of the movie My Fair Lady. That's basically what it is. I can see that very few people know what is the movie My Fair Lady. No? Okay, look it up and watch that movie, okay? And then what happened to the main character in that movie is getting refactored. Any other questions about this? I'm not sure about pull up and push down. I think that has to do with methods and definitions. Do you want to pull it up in the class hierarchy, or do you want to push it down in the class hierarchy? So let's take a look.
That's what it says in Wikipedia.
Okay. Members in interfaces cannot move because I'm highlighting in interface at this point. So if I go to basic adapter, which is a class, and go to refactor and use push pull up. So it is looking at the members and select destination type. Yep, so that's what it's doing. It's allowing me to change the location of my methods. I can push it up the hierarchy, I can push it down the hierarchy, which is kind of cool because occasionally you want to say, well, this subclass has a method that I should have made it a part of a superclass. That allows you to do it. Yep. All right. Well, that's a nice discovery. I'm still in the good old days of using just VI and the command line compiler tool to do my own development. The world is just whizzing by. But these tools are definitely useful, because once you understand the concept and why you might want to use the tools, it allows you to apply the changes quickly and reliably. but it does not take the responsibility away from a developer to understand why you might want to do something like this, or why it is a useful, thing to do when you push up or pull up or push down a particular method. Right. So I think I'm gonna stop the lecture at this point. We are not entirely done yet. We went through a lot.